Mrs. McTaggart here. I'm going to show you in this video a quick recap of all the different types of further integration you do at higher, including how to integrate sine and cos and to do the chain rule in reverse. So you may or may not have already seen this. This is my handy hint to remind you how to differentiate and integrate without having to look at your formula sheet. You simply write down sine cos minus sine minus cos, or you could even shorten that to SC minus S minus C if you don't want to write it all out. We use a wee bit of alliteration, D for down, so when we differentiate we work our way down the list, and when you integrate you increase and work your way up the list. So we're working on integration today, so if you integrate negative sine, that goes to cos, so it goes to positive cos. If you integrate cos, that goes to sine. And if you integrate sine, well, that comes all the way back to the bottom, and sine would integrate to minus cos. And I find this really helps when you are having to integrate maybe two terms and there's a negative in front. It avoids a double negative and it's just really handy. So let's have a look at this in action. So before I start, I'm going to write out my little sine cos, sine cos. So sine cos minus sine minus cos. Okay, that's all it took. And I'm integrating, so I'm going up to date. So when you integrate sine, so using my little thing, sine means I come all the way back to the bottom, sine goes to negative cos. So my first term, when that's integrated, when that's integrated, that goes back to negative 3 cos x. And then my negative cos, when I'm integrating, would go up to minus sine. So negative cos becomes minus sine x. So see how I don't need to worry about my signs at all there? And don't forget, incomplete it will always be unless you remember to add on C. Another one of my wee silly rhymes. Okay, let's look at part B. That's part A done. So part B, when we integrate, we're then going to substitute in some values. So what I'm going to do is I'm going to come down here for part B. So when you integrate cos, work your way up. Cos goes up to sine. So that would be root 2 sine x. And then we're integrating minus sine, so minus sine goes up to cos, so that turns into plus cos x. And then we have to evaluate this between pi over 4 and 0. So if I'm substituting in pi over 4, I'm going to get rid of my wee diagram now. So if I'm substituting in pi over 4, remember that's just 45. So I've got root 2 times sine 45 plus cos 45 for my first bit. Take away root 2 sine 0 plus cos of 0. Now, sine 45, if you remember, comes from your isosceles triangle of sides 1 and 1, because that makes your angles 45. And then that side is root 2. So cos and sine 45 are both 1 over root 2. So we've got root 2 times 1 over root 2 plus another 1 over root 2 for your first thing. And in the second one, sine of 0 comes from your sine graph. So remember your sine graph, sine of 0 is just 0, plus, and then cos of 0 is 1. Okay, so let's move them out the road. So now let's evaluate what we've got. So this root 2 and that root 2 are going to cancel out. So we have got 1 plus 1 over root 2, and then this will become negative 1. Those ones disappear and you're just left with 1 over root 2 units squared. So that would be that one, 1 over root 2. Alright. And just a wee reminder, there isn't a C term on this one because it's a definite integral and I'm substituting in numbers, so the plus C's would cancel out there. So you get taught the chain rule, you get taught differentiation, you get taught integration is the complete opposite. That's still the same. Now my wee mantra for when you're integrating is I always say raise the power, divide by the new power. Now that's still there when you're using the chain rule inverse. You still raise the power and you still divide by the new power. But whereas, oh there's a wee spelling mistake there, look at that. That should be differentiated. Whereas with the chain rule for differentiating, you times by the differentiated bracket. Now we divide by the differentiated bracket. And you may or may not have seen this little like general formula here. So just to explain what's happening here. So following my mantra, you raise the power. So the power was n, that becomes n plus 1. So we've raised the power. We then divide by the new power. So we divide by whatever that new power was, n plus 1. And then we divide by the differentiated bracket. Now when you differentiate that bracket, ax goes to just a. And when you divide by that, yes, it goes to the bottom of the fraction, but it's actually going to be multiplying by the power. So the bottom line is actually your new power multiplied by the differentiated bracket. And we'll see that in action in some of the examples, okay? So let's go. So question 2, we're going to integrate this first term. So let's follow the steps. So we raise the power, so we leave the bracket as is. We raise the power to 4. We divide by the new power, which is 4. And then when you differentiate 4x, you get 4. So we have to divide by 4. But remember, that comes to the bottom as well, and they actually end up multiplying. So that leaves you with 4x minus 9 to the power 4 all over 16. Now, it's your personal choice because technically you could also write this as that. And sometimes if you're doing this from a textbook, it will have it written like that as 1/16 in front of the bracket. So they are your options on how to write your answer. Either would be okay. But remember one thing I've forgotten, incomplete will always be unless you remember to add on C. And I nearly forgot that there, so be careful. Okay, the second one needs a wee bit of prep before I can even think about integrating it. So I'm going to bring that up to the top. So that's going to be 4 bracket 4x minus 9, and then square root is a power of half. And because I brought it up from below, it's actually negative 1/2. Right, so let's integrate. So when you integrate that, remember, you keep your bracket as is. You increase your power, so minus 1/2 becomes 1/2. You increase your power, you divide by the new power, and you divide by the differentiated bracket. And when you differentiate 4x, you get 4. Okay, now there's 2 ways to look at this. You could do half of 4 is 2 and then cancel the 4 and 2. But I just want to remind you of another way of doing this. So let's say those 4s have cancelled and they're gone. Remember, when you've got a fraction on the bottom like this, effectively the denominator of the half comes right up to the top line, because dividing by a half is the same as timesing by 2 over 1 technically. So this 2 here comes up to the top, and that gives you 2 bracket 4x minus 9 all to the power of half. And if you wanted, you could have put that back into into the square root. So just to recap what I did there. So technically, yes, at this point here, where I've got the red pen, I could have done a half of 4 is 2 and then done 4 divided by 2 to get me the 2 that's in front of the bracket. But I just wanted to remind you that if you're left with a fraction in the denominator of the denominator basically comes up to the top line, and that's a wee handy thing to remember. And I don't think any of my other examples actually have that. And again, look, I forgot to add on my C. So I'm just going to go put that in at the last wee minute. So that's something to always check if you've got extra time. Incomplete it will always be unless you remember to add on C. Okay, question 3. So I need to use my sine cos. So sine cos minus sine minus cos for this one. And we are integrating, so we are going up the way. So negative cos, move up from negative cos, gives you negative sine. So this is just negative sine x. Negative sine 7x. But remember, this is a bit like having a bracket around the 7x, so you have to remember to divide by the differentiated bracket. So we have integrated the cos as normal to get minus sine, but then you have to divide by what you get when you differentiate 7x. So you have to divide by 7. Don't forget to add on your c. Now you can either write it like that, or you could write it as 1/7 in front again. It is your personal choice. Okay, so that's that one. For the second one, so next one. So we're going to integrate sine. So sine can't go any higher, so you have to come all the way back to the bottom. That gives you minus cos. So this becomes minus cos of your bracket. So 3x minus 1. And then when you differentiate the 3x, you get 3. So you have to divide by 3. So that becomes negative 1/3 cos of your bracket. But remember what I said, I don't mind if you leave it as all over 3. When it comes to substituting, it actually is easier to leave it as a fraction form. It's up to you. Okay, so here's one we've got to do actual values, so definite integrals. So sine, cos, minus sine, minus cos. So cos goes up to sine. So this becomes sine 2x. And remember, you have to divide by the differentiated bit. So differentiate 2x makes it all over 2. And then I'm going to actually take that as minus sine. Minus sine integrated comes up to cos. So that becomes plus cos 4x all over 4. And this is going to be between pi over 2, which I'm going to make 90, and 0. So this gives you sine of 90 doubled is sine of 180, and then halved, plus cos of 360, and then quartered. Take away sine of 0 halved, plus cos of 0 over 4. Okay, sine graph. Sine of 180 is 0. So the first term is just 0. Your cos graph, if I squeeze it down here, your cos graph, cos of 360 is 1. So you've got a quarter. So you've got 1 over 4. Take away sine of 0 is 0 again. And cos of 0 is 1. So it's 1 over a quarter there. And then when you tidy that up, you've really got 1/4, take away a quarter. So what we've actually got here as an answer is 0. Okay, so that turned out to be a 0. And then what I thought I'd do is I'll show you a couple of exam paper questions again. So this one came from 2019 and it was integrating and then subbing in the value of pi over 9. So sine, cos, minus sine, minus cos. So cos, when you integrate, goes up to sine. So this becomes the integrated, this becomes sine of your bracket. In fact, see that pi over 6? I'm going to turn that into 30 just now. So pi over 6 is 180 divided by 6, which is 30. And we are then dividing by what you get when you differentiate 3x. So we need to divide that by 3. So it's all over 3. And then pi over 90 is 180 divided by 9, which is 20. So we're going to sub in 20 and 0. Right, so when you sub in 20, this becomes 3 times 20 is 60. 60 take away 30 is 30. So this becomes sine 30 all over 3 for the first term. Take away sine of 0. 3 times 0 is 0. Take away 30. So sine of negative 30 all over 3. Right, sine of 30 is a half. So we've got a half divided by 3. Please remember, a half divided by 3 is the same as a half times 1/3 when it's flipped, so that's 1/6. Sine of 30, minus 30 is here. So the acute angle associated with the horizontal is still 30, but this is a cos box, so sine is negative in there. So this bit of sine of negative 30 is the same as negative sine 30. So this is minus 1/2 divided by 3. So minus 1/2 divided by 3 is minus 1/6. So you end up with 1/6 plus 1/6, which is 2/6, which equals 1/3 for that one. Okay. Okay, so first thing we have to do in this one from 2008, this is worth 5 marks, is we have to prepare this for integration. So the bit on the bottom comes to the top and becomes 2x plus 9. Now, the cube root and squared, my wee chant is the bottom becomes the root, the top stays put. So the root was the bottom, so this is the power 2/3. But because I brought it up from the bottom, it's actually negative 2/3. Right, let's get ready to integrate. So when you integrate this, your bracket stays the same. So 2x plus 9 minus 2/3 raised by 1 goes up to 1/3. we divide by the new power, and we divide by the differentiated bracket. Now, when you differentiate that, you get 2. So we're working with this. Right, let's tidy up that bottom. 1/3 times 2 gives you 2/3. So the 2 stays in the bottom and the 3 comes up to the top. To the power 1/3. Okay. And then we're going to plug in the numbers 9 and -4. Now, because it's a power of third, I'm going to rewrite this as the cube root. So let's come up here. So this is 3 times the cube root of 2 times 9 is 18. 18 plus 9 is 27. So there is my first sum. Take away. And then if I plug in -4. 2 times -4 is -8. Plus 9 is 1. So I've got 3 times the cube root of 1 all over 2. Okay, let's start. Cube root of 27 is 3. 3 times 3 is 9. So I've got 9 over 2. Minus, cube root of 1 is just 1. 3 times 1 is 3. So -3 over 2 for my second term. So I've got 9 halves minus 3 halves, which is 6 halves, which is 3. And I can't spell units. So it's 3 units squared. Okay, so my last example is a bit trickier. It's worth 6 marks. It comes from 2018. So in this one, they tell you what your answer is. They just don't tell you what A is, and that's what we have to work out. So we go and we integrate as normal. So sine cos minus sine minus cos. So sine integrated has to come back to the bottom and gives you minus cos. So we are working with negative cos of 4x minus pi over 2. And then we divide by the differentiated bracket. Differentiate 4x is 4. So this is all going to be over 4. And this is from A to pi over A. So then we're going to sub in. So you have negative cos 4x, sorry, it's 4a because x is being replaced with A. All over 4. Take away, then we're going to sub in pi over 8. Which gives you negative cos. 4 times pi over 8 is 90. Take away 90 is just 0. So this gives you cos of 0 all over 4. And we're told that that equals 1/2. So I've kind of set up a wee equation. So I've got negative cos of 4a minus pi over 2 all over 4. Plus, now cos of 0 is just 1, right, from your cos graph. Remember, cos of 1 is cos of 0 is 1. So that is going to become plus 1/4 equals 1/2. Now at this stage, I can get rid of all these fractions. If I times absolutely everything before, these fractions will disappear. So that would give me negative cos of my bracket. I'm going to change that to 90 just now. Cancels with 4. 1/4 times 4 is 1. And then 1/2 times 4 equals 2. So I've now just got a wee trig equation. What I'm going to do is I'm going to move that 1 over. So 4a minus 90 equals 1. So I have cos, if I take that negative over actually, I am solving my cos graph equal to -1. Now your cos graph only has one answer of -1, which is right in the middle, which is 180. So this bit here in the bracket equals 180. So 4a minus 90 equals 180. So 4a equals 270. So a is 270 over 4. Now the question was in radians, so I'm going to go try and change that again. So if I actually go back to this line here, it's easier to think of that as pi. Pi plus half pi is 3 pi over 2. So that was 3 pi over 2 divided by 4. So that is 3 pi over 8. And that is your answer to that one. So that is a wee bit trickier, but just to make you aware that they can give you them. So thanks for watching. I hope that's helped.